Okay, so what I want you to do is try and find the point group of the molecule that you have. And I'm going to hand you a character table. We'll look at that in just a minute. Constanza, you got it easy. What's methane? TD, yeah. So tetrahedral is a shape that a lot of molecules can have, but in order to have tetrahedral symmetry, all the ligands need to be the same. And we label that TD. Let's see, who else has figured theirs out already? What do you think? All right, so we've got ammonia. That's another easy one since we've done it before. C3B. All right, Chase, you got yours? You have formaldehyde. Grab the oxygen. Okay, rotate it 180 degrees. So you got a C2 axis, so it's not just CS. It does have vertical. So it's C2B. No flipping it upside down, so it's not in the D groups, and no horizontal axis. Okay, so let's see, yours would be bromine. We're gonna call it F2Cl. Okay, so you got a C2.
Yep. You're playing.
Is it vertical or horizontal?
It is.
Vertical. Okay, any flipping upside down?
Nope.
Nope, so it's not a D. It is also C2. All right. Jenna, what do you got? C5H5 minus is actually aromatic. So in resonance, we assume it's all the same bond all the way around. Yeah, so it's C5.
C5, it's a vertical, right?
It does have vertical, but if you lay it flat, can you flip it upside down and it still be symmetric?
Yeah.
Yep, so it's in the D groups.
So D5H.
Horizontal. D5H. All right, so, and that is D5H. All right, Abby, what about yours? You got a metal in there? We're gonna call that, let's call it FeCl5L. C4V. C4V. Good. Caleb, what about you? I gave you a tricky one. Axis, so it's in the D groups. So C3H4. All right, so if I hold it so that the bottom one is towards me, top one is towards you, and then the top one is towards me and the bottom one is towards you, and then I rotate it like this. Oh, did it flip there? Okay, I did that wrong. How does it work? It goes there. That's it. D groups and D2. And if it's hard, it's not H, so D2D. D2D is D2D. All right. Katie, I'm tormenting you with this group. What do you got?
Well, now I was gonna say
This is
C1, like I'm thinking you're saying CS.
it is CS because it's got that mirror plane straight down the middle.
How did I not see that?
I'm just gonna keep giving you that one
Yeah,
until you
please
remember.
do.
And Tanea, you have benzene. So benzene will be very similar to the cyclopentadiene.
It's freaking mirror plane. I can never
C6H.
see it.
I'm sorry, D6H. You probably said that and I said it wrong. Okay, so we have all of these different point groups. Now I have passed out to you a packet that has different character tables. And so I want you to find your point group in those character tables. And if I got the correct one, they should all be in there. Okay, so remember for a point group or for a character table, we have the different symmetry operations across the top. Okay, so each group of like symmetry operations is called a class, and you look at the coefficients of the class. Don't forget that the ones are invisible, and you add up those coefficients. So Katie's is at the top there, the CS group. So what is the order of CS? So you're going to add the coefficients of the symmetry operations at the top of the character table. Yes, so that's going to be an order of 2. Let's see, we had several in the CNVs. So if you had a C2V, that's the first one listed about midway down under the CNV groups. This is the same one that water is. What is the order for CNV? Let's see, Chase and Caleb both had C2V. And add up the invisible ones. We're just looking across the top, looking at the coefficient of E, C2, sigma, and sigma. So add those coefficients. 4. So the order of the group is 4. Very good. And this is why we're doing this, is so we can ask those questions and make sure that we're getting to the right place. All right, Abby, you had C4V. So what's the order of your group? 8. So if you look at the bottom of that front page, notice there are only 5 symmetry operations, but it's 8 because she's adding the coefficients. All right, and then let's see, Lucas, you had C3V. All right. B6. Yes. All right. And Wyatt, I think I skipped over you before. You have D2H. Did anybody have a CH group? I don't think anybody did. Okay. We'll skip that. All right. Caleb, you had D2D, so that's on the second page. All right. I would agree with that. Okay, then going over to the D and H groups. Let's see. Wyatt, you had a D2H. We got a lot more things to add here, but they're just the invisible ones. So on the third page, the second group down should be D2H.
8.
8. Yeah, so there's 8 groups. They all have a coefficient of the invisible one. So 1 plus 1 plus 1, so on, is going to be 8. All right, and let's see, who haven't I done? Flip over to page 4. Jenna, you had D5H. What is the order of your group? Let's see, I got to do that math real quick. Yes, 20. So she's actually got a 5 for one of her coefficients, so it's getting to be a big number there. Even bigger for Tanea right underneath that. Give you a minute to count those up. 24 for D6H. So we're adding the 1 plus the 2 plus the 2 plus the 1 plus the 3 plus the 3 plus the 1 plus the 2 plus the 2 plus the 1 plus the 3 plus the 3. And for yours, are you adding the invisible one next to E? So at 24. So notice they're all even numbers, and that will always be the case. So if you're getting an odd number, either you forgot that you're adding the coefficients, not just counting the number of groups, or you forgot E. This is called the order, and it is represented with the letter H. Okay. So we have different labels that are there, and I had given you on this packet, there was a little bit of talk about those different things, but I'm gonna write out what they are on the board here so that you have it written in your notes and you have it processed in your brain at least once that way. Okay, so whether you use E's or T's or primes or G's is going to depend on what symmetry operations are in your group. But everything has at least a C because the rotation for the identity is C1 going all the way around. So first thing you do is find the principal rotation. And for yours, that might be a 2. We had a couple of 5s. We had a couple of 6. It's whatever the highest number is.
What is it, like, what are we finding, like, the overall?
We're just saying what the labels are for the irreps. So, and the irreps are the things that are like A1 and EU and things like that. Okay, so when you find that, then you look at what things are going to change sign when you rotate around that and what things don't. And so if it is A, then under that first operation, and if you look at your character table, the C for your group should be right next to E. So E is the identity, always listed first, and then the primary rotation is always listed second. Now, if you have CS, like Katie does, you'll notice there's no 1 or 2, and there's no Bs. So if we don't have anything beyond C2, then we just don't use the Bs. Okay. And then under B, it will be -1. So double check this in your group that anything that is labeled 1 has a +1 under that second column with the primary rotation. And anything that has a B has a -1 there. Is that checking out for yours?
You said that B has a -1 for all of them?
Not for all of them, just under the C. So let me pull up an example. So I'm looking at, let me look at D4H. We're going to look at D4H later. If you figured it out on yours, keep looking at yours, but otherwise keep looking at D4H. So E is the first column, and then next to it is the C4. So if I look under C4, some of the irreps have 1s, some of them have -1s, some of them have 0s. Anything that is a 1 is labeled with A as the irrep on the left-hand side. Anything that is a -1 is labeled with a B on the left-hand side. Does that check with what you're doing? Yeah. Because, that's a really good question. I don't know. I guess the DND groups do it with the improper rotation rather than they're using the -1s there. So I guess in the DND groups, they use the improper rotation for their primary axis. The DNH groups, it's still going to be your C5, your C6, your C2. So it's whatever is right next to E. That's what's determining it. Okay. If you have an E, this means that you have a doubly degenerate irrep. What does that mean? That means you have two things that are part of your basis, usually things like the X and Y axis. So the X and Y axis are pretty similar, and they're going to start exchanging places. So as I rotate 1/5 of the way around the molecule, the X starts moving into the Y space and the Y starts moving into the X space. Okay. If I have a T, that means it is triply degenerate. And this will happen if you have a kind of a non-perpendicular C3 axis, like in the tetrahedral groups or the octahedral groups, where you can turn X into Z, Z into Y, Y into X. Okay, so the Z axis is always labeled as A. And it is almost always labeled with the very first irrep. The first irrep is considered the totally symmetric representation. So 1 tells us that it's symmetric under that operation. So the totally symmetric representation will be all 1s. So if you look at your point group, you're going to see the very first one going across. It's just going to be a bunch of 1s. Okay. This represents the S orbital. And often, but not always, the Z orbital. All right. Check to see in the column after all of the 1s and -1s and things, the column after that, these are called the linear operators. See where the letter Z is. Is it in an A?
Yeah.
And here D2D is just going to be weird on me. We're going to pretend D2D doesn't exist. But pretty much all of the others, Z is going to be in the A groups, okay? Because our Z axis is our primary axis. So if I'm rotating around that, Z is basically just turning in place, pointing up. All right, so the reason it's different with yours is it's using the SN axis instead of the Z axis. All right, for X and Y, if your principal axis is 2, then X and Y will probably be labeled B, but have different subscripts, right? So if you look at D2H, I think that's Wyatt's. Oh, I'm looking at the wrong one. There we go. The Y is labeled B2U and the X is labeled B3U. Okay, so X and Y are often labeled with B if there's a C2 axis, if that's the primary axis. But if it's not, then I'm turning part way and turning the X into the Y and the Y into the X. And so they'll be combined together in the E. So you will see X and Y like this. Okay, so if your primary axis is greater than 2, you probably have X and Y labeled as E. Unless you have one of those really high symmetry ones, yours is probably labeled 3 or T rather. And it probably has X, Y, and Z together. Okay. So that's what the A's, the B's, the E's, and the T's are telling us. Okay. Then we have ones and twos. So what you do with the ones and twos depends on what symmetry operation you have. If you're in a D group, you should have something labeled as C2 prime. That's that perpendicular C2 axis that makes it in the D groups. So for D groups, you're going to look under C2, C2 prime rather. So that's that perpendicular C2 axis. All right. So if you're looking under there, if you have a D group, you should see a 1 if it is symmetric, or if you should see a 1 for the label if there's 1 under the column, symmetric. Okay, so if you're in a D group, look at yours. If you're not in a D group, just pick one of the D groups. So I had been looking at D4H before. I'm not looking at the first C2 that I see. I'm going over until I see C2 prime. Okay, under C2 prime, if there is a 1 under the C2 prime, the label of the irrep on the left is 1. If there is a -1 under C2 prime, the label of the irrep is 2. Okay, this is one that will probably mean the least to us. It's less important to know this symmetry than it is the A's and the B's versus the E's. But this is where that number comes from. Questions about that? Were you able to verify? So what if you don't have a D group or C groups? Wait, you have D6H, D5H. Yours is, okay, there's no prime on it because since 5 is an odd number, there's only one C2.
Okay.
Yeah, so it's just that. Okay, if you're in the C groups, you don't have a perpendicular C2. So look at the C and H groups. So this isn't going to apply to all the C groups, but if I look on, I think it's page 2, where I have C2H, C3H, C4H. No, and they're not doing it there on that one. Probably because of the inversion center. Oh, no, it's the vertical. Sorry, not horizontal, it's vertical. Vertical miracle. So C and B. Have that backwards. if I look under one of the vertical mirror planes, usually the one listed first, if there's multiple ones, the label will be 1 if symmetric. Label will be 2 if antisymmetric. So if we look at Waters group C2B, there's an A1, an A2, a B1, and a B2. Okay, and so we don't have that perpendicular C2 axis, but we do have vertical mirror planes. Okay, so underwater for C2V, if I look under sigma V, this one, the first one is labeled XZ. The A1 has a 1, the A2 has a -1. The B1 has a 1, the B2 has a -1. All right. So this is another reason why I don't worry about this one too much, because it means different things in different places. Okay, so you know where they come from, but I probably am never going to ask you that unless it's like in a homework assignment, just so you can look it up. All right, the next one is only for groups that have an inversion center. So C and H has an inversion center, and most of the D groups have inversion centers, not the D and Ds, but most of the other D groups have inversion centers. So G versus U. If there is an inversion center, and again, if you look at D4H, that has an inversion center, means, and the inversion center is I, so we're going to find I on the top row and look down that column. All right, so on that top row, we look for I. Underneath there, the first one,
GU.
the label either G or U, just like we could have a label 1 or 2.
Okay, that makes sense.
Yeah, so if you're seeing either a G or a U, this is where it's coming from. It will be G, let me write it the same way I did before. The label equals G if symmetric under I, which is a positive one, which means that if there's an inversion center, that first row across will have a G in it. It'll be AG or A1G. The label will be U if antisymmetric. All right, so can you verify that under one of the groups? Yeah, Jen.
Clarification, like, will you make symmetric and anti-symmetric?
It means whether it's a 1 or a -1.
That's it, okay,
Mhm.
I just want to make sure.
What is meant by that symmetric or anti-symmetric is going to depend on what objects we're dealing with, our basis set. So if our basis set is axes, axes are not symmetric with respect to inversion because positive becomes negative and negative becomes positive.
Okay.
All right. And then the primes deal with the sigma H, if there is one. That's where I got those confused. And much like this one, I don't really care too much about the primes, but it's basically going to follow this same rule for sigma H, if it has prime or double prime. Yes, Abby.
But why does one of the G's have a 2?
Where?
G on D3B.
Because the 2 is coming from this. So it can have more than one of these labels. Or are you looking under I?
Looking under I.
So which point group are you looking at?
Or the other.
Those are the weird ones. Let's ignore the D and Ds. Yeah. It's because it's doubly degenerate. So like, just think positive or negative. Since it's negative, it's U. If it's positive, it's G. It just means two things are positive versus two things are negative. All right, so that's a lot. Okay, so the online text and the what do you call it? Miesler and Tar text both try to do this next stuff with matrices. And I don't know about you, but matrices are not the easiest way for me to think about this. If you love matrices, I'm happy to go back through with you and deal with matrices, but I rewrote this based on how it makes sense to me. So what do we use these point groups for? One thing we can use these for is to tell us if a molecule is polar. So things that make something non-polar. Well, water has a mirror plane. Is water polar? Yeah, so having a mirror plane is okay. That's allowed. What about an inversion center? So if we think about polarity, you're pulling more in one direction than the other. An inversion center says we have exactly the same thing on opposite sides, right? So if I have an inversion center, it can't possibly be polar. If I have a horizontal mirror plane, then it can't be polar. And if I have a perpendicular C2 axis, it can't be polar. So there's kind of an explanation in there. But the sum total of all of this is for something to be polar, it needs to be in one of three groups or three sets of groups. CN, where it just has a number, CNV, like this, C2V, or CS. So based on your point group, think about whether your molecule is polar. All right. So is TD one of those groups? No. So yours is a non-polar molecule. Okay, Lucas, what about yours? Is yours polar? Because it's what point group? C3V. All right. And then Chase, what about you? You had C2V. So is that polar? Yeah, because it's just like water. And Katie, what about you?
Yes.
Yes, so CS is going to be a polar group. All right, anything with a D at all is going to be non-polar. So what do you think, Caleb? Non-polar. Jenna? Non-polar. Okay, so Jenna had the D5H. Caleb had the D2D. All right, you had C4V. So polar or non-polar? Polar. And then Tanea, what about you? You have non-polar. Okay. The other thing we can tell just by looking at the point group is whether or not it is chiral. What does chiral mean?
Means it has 4 different bonds.
And that is not what chiral means.
Or
Well, like, it's attached to a
like
carbon, it
it's
has three
attached to it.
So a way to tell if a carbon is chiral is to determine if it has 4 different groups. What chiral means is that it will rotate polarized light.
Oh,
That would have got me.
well.
So when you're in organic chemistry, all you got to worry about is the carbons. And if your carbons have 4 different substituents, then yeah, that's how you do it. But we have things with 5, with 4, with 6. So we need a different way of looking at this. Okay. So if it is chiral, then it can't have any mirror planes at all. Okay, no mirror planes, no inversion center. The only thing that it is allowed is rotational axes. Which means, is C and V allowed?
No.
No, because it's got vertical mirror planes. Is CS allowed? No, because the S stands for mirror plane, right? So the only rotations would be only if it is CN. Do any of you have a chiral molecule? No. Okay. If you're in lab, 5 of you are in lab, we used this compound. I'm not getting it exactly right. But as long as that stayed flat like that, which we know molecules are kind of floppy, they'll move around. But as long as it stayed flat like that, it would be chiral. No, it wouldn't be chiral because it has a horizontal mirror plane. Okay, let's say that all of these oxygens were pointed towards us. There we go. Oops. Right that way. So now we've gotten rid of that horizontal mirror plane. So we've got these OH groups sticking out and the hydrogens kind of sticking to one side. So these have kind of a pinwheel shape. Okay. Anything that has that pinwheel shape, as long as it's not flat, is typically going to be in one of these groups and will be chiral. Okay, so did I give you the handout?
This one?
Yes.
Yes.
So if you look at the recycling symbol, notice how you have the arrows pointed in one direction, counterclockwise, or in the other, clockwise. But if I flip those over, then they're not going to look the same on the back. The arrowheads would be in the back instead of in the front. Okay. So those would fall into the C3 point group. Okay. The same way a pinwheel, when wind blows on it, it's only going to rotate in one direction. For a molecule that's in the C3 group, the light will only rotate in one direction. Okay, I saw a hand. Was it you, Lucas?
So how does giving them like that like pointing to you, the wedge, how does that give it like only rotation? How does that get rid of the mirror plane?
Because the mirror plane was the plane of the board. It was the same if you flipped it over.
So imagine if you like cut like the oxygen in like half.
Like if you cut every atom in half, right? There's a mirror plane, front to back.
Yes.
And mirror planes are not allowed. But if all of these are coming forward and I try to put that mirror plane there, then they would all be going backwards.
Because they would all.
Yeah. Okay. Really quickly, since I have this set up, I want to show you some different vibrations. So I can calculate different vibrational modes on this. Some of them are going to be visible and some of them are not. Let me see if I can make this guy bigger. There we go. All right. In the IR, I can only see things if it changes the polarity of the molecule. So there are 4 possible vibrations that are stretches. Here's one. I'm getting some exercise there. Am I changing the polarity? So in order to change the polarity, I kind of have to change sort of the center of gravity of the molecule. Anything that destroys that inversion center will create polarity. So when I stretch out opposite sides, am I changing the inversion center? No. Okay, so you'll notice on the bottom where that green line is, that's where that stretch should appear. And if I take it away, there's no peak there. Okay, but I do have something right about here. And that is this guy. Oh, nope, that's not that guy. That's another one that doesn't appear. So that's basically just getting bigger and smaller. Can't see that in the IR. But then I have 2 that we can see.
Okay.
And so you can kind of see the middle of the molecule wiggling a little bit. And so those I can see in the IR, even though this is a nonpolar molecule, that's changing the polarity of the molecule. So it shows up in the IR if it can do that. I can also change This is a torsion, it's twisting it in and out of plane. This is twisting it in and out of plane. And this is making the angles bigger and smaller. All right, so those are some of the different things that we mean by bends versus stretches versus torsion. Okay, so take a look at what I handed you, read through that, and then we'll talk about on Monday. Oh, and I sent on Canvas, you'll see you have an assignment for a survey. Would you like your quiz next Friday before spring break? Get it done, then you don't have to think about it? Or would you rather have it on the Monday you get back from spring break? And then you have to.
Right.
All right,
Yeah,
answer the survey. Answer the survey.
No way. I wanna make it.
Yeah, I just want.
In about 2 weeks. For us.
I figured it was something important.
Yeah.
The quiz on the modules on that main page, for chapter 4, I've listed a quiz, I think it's from 2020. That pretty closely covers that material.